3 years ago, I was a robotics consultant here at mHUB, and at that time, the way that you got a robot to do something is that you wrote code by hand. And although that was relatively recently, that is now basically ancient history. So today, the way that you program robots is that you teach them by demonstration, right? So you teleoperate them, you treat them kind of like puppets, and you show them what to do. That becomes training data that goes into a neural network. And then those models are used to create policies for the robots. This is basically the next chapter in robotics. All of the major robotics labs have adopted this approach. And I think it's important for the mHUB community to know about, and I want to talk about it here because it has huge implications for US manufacturing. So US manufacturing today has a major bottleneck. There is a huge rush for onshoring right now, but we still don't have the massive cheap labor supply that our competitor countries have. And oh, by the way, also half of our existing workforce is about to retire. Basically, anything that requires dexterity in assembly needs to be done by hand, and there are not enough hands. So this includes basically all of medical device assembly and wiring harness assembly and a huge chunk of electronics manufacturing services. And these are just 3 subsets of the overall assembly market that make up billions of dollars spent every year. We are not going to be able to solve this problem with the solutions of the past. And this is what the assembly line of the future looks like. So these robots are not traditional automation. They are doing things like handling flexible wires and seating gaskets and plugging in connectors, right? The thing that the majority of the industry has not figured out yet, however, is what I call the last millimeter problem, right? These neural networks, these vision language action models are very good at getting the connector all the way to the plug. But that last millimeter, they fail catastrophically. And it turns out that the secret is that you need the sense of touch in order to navigate the complexity of the last millimeter. Now, we at Fluid Reality, my co-founder and I, figured this out the hard way. We spent 15 years doing haptics research, understanding teleoperation. But what that allowed us to do is to get out ahead and invent a technology that allows people to feel what robots feel. It allows the teleoperators to feel the fine sense of touch when they're doing this training. We invented electroosmotic haptic actuators. This is what they look like on the right-hand side. That's a finger for scale. And they are 100 times smaller and 100 times cheaper than any alternative. What that allows us to do is to build it into these leader-follower systems. Yep, sorry. Build these into these leader-follower systems where the follower robot is basically following everything I do, my finger movement, my arm movement, and I am feeling on my fingertips what those red robot fingertips are feeling. This allows us to do these last millimeter tasks and allows us to create high quality data. So the robot operator goes from this kind of one-to-one training to graduating to being the supervisor of the line. They're overseeing 5 robots, in the future 20 robots. We sell based on a video game sales model, meaning that we reduce the cost of the hardware as much as possible to lower the barrier of entry, and then make our money on the software side. We very specifically tie our profits to the throughput of the customer. So they make money, we make money. What this low barrier of entry allows us to do is to go to market with a much lower productivity increase. So with just a 25% productivity increase, these systems pay off to the customer. Then once we're in the door, the data starts to accumulate, the models get better, the robots get better, and productivity and our revenue increase naturally. So our path to 100 million ARR goes through 1,600 customers of approximately $65,000 average subscription value. To date, we've done a lot with a little. We're a pre-seed company, but we have $500,000 in pilot projects completed. We have ongoing LOIs in robotics worth over $1 million. We have an ongoing NSF SBIR project for $300,000 with a match from the state of Illinois. And this current fundraise is about demonstrating that system at a customer facility and doing the cost-benefit analysis, measuring exactly what the productivity increase is for the system. The team behind this is based here at mHUB. We do our fabrication downstairs. My co-founder Craig and I have worked together for over 12 years. We've built 3 products together. For me, this is my 3rd physical product startup that I've founded. And we're advised by people like Ed Colgate, who is the original inventor of the cobot, now the current director of the largest dexterity-focused research program in the country at Northwestern. So here's the bet. The world has already changed due to AI. Robots are now trained by example. They're not programmed. Every robotics company in this space is going to have to solve the last millimeter problem, and we're raising to deploy the first solutions to it. So if this dynamic future of American manufacturing is interesting to you, please get in touch. And if you would like to feel what robots feel, we have a demo downstairs in the hall, and you can see me on the way out. Thank you.
All right, next up to the stage is Forever Analytical. Let's give them a round of applause.
Hi, my name is Hunter Macmillan. I'm the co-founder and the CEO of Forever Analytical. We build portable modular systems that help detect toxic contaminants on-site in minutes instead of weeks. Our initial market is PFAS. You've probably heard of these before. They're called forever chemicals, and they represent one of the most pressing environmental challenges of our time. And perhaps the biggest problem with these chemicals is we lack tools to determine where they are exactly at scale. So I've given it away a little bit, but what do all of these products have in common? Unfortunately, they contain PFAS. And these chemicals are widely used because they're resistant to heat, oil, and water. And these same properties also mean that they're chemically stable. In other words, they don't break down in nature, and they don't break down in the environment. Instead, they bioaccumulate in our blood, in our soil, and in our drinking water. And again, the biggest problem is that we lack the tools to monitor for these at scale, so contamination can often go unnoticed for years. Unfortunately, they now estimate that more than 95% of Americans already have PFAS in their blood. There's numerous scientific publications that link these to negative health effects, including things like hypertension, cancer, and the list goes on. Governments are now responding and banning and aggressively regulating these chemicals. But unfortunately, we lack the tools to monitor for these at the scale that regulators now are requiring. So what do most PFAS laboratories do today? They rely on a method called Method 1633. It's expensive, it's extremely slow, and it's capacity constrained. A sample can take 3 to 4 weeks to return results. And the price per sample ranges from low hundreds of dollars to high thousands of dollars. And they only measure for 80 individual PFAS compounds, when they estimate that more than 3 to 5 million of these exist in the environment. So industry's solution today is to have something that's expensive, it's slow, and it's drastically incomplete. Our solution solves this problem. It's a portable system for detecting PFAS rapidly on-site. Our technology focuses on looking for total organic fluorine, which is the chemical fingerprint of PFAS, and our analysis takes under 3 minutes. So this allows users in the field to make real-time decisions without having to send samples off to a laboratory for analysis. So this means your regulators, your environmental remediation firms, manufacturers, wastewater utilities can get real-time on-site decision-making capabilities. And this technology is built to scale. Instead of looking at a small subset of 80 compounds, we're looking at total PFAS levels. The solution itself, the physical solution, is designed to be rugged, it's portable, and it seamlessly integrates into existing customer environments. And global regulation is only increasing the demand for these types of solutions. The European Union and the United States are already banning these chemicals, specifically in consumer products, drinking water, textiles, manufactured goods, and the list goes on. But what this means for industry is you now have a global compliance set that you have to mandate and build your products around. So what regulators are doing is they're creating millions and millions of new samples that now need to be tested. And existing laboratories lack the capacity to do it. As you can imagine, this is a large market. It's a global PFAS testing and remediation market is already estimated to be well north of $100 billion. At Forever Analytical, we're focused on the high profit margin, high growth segments within it. So wastewater, consumer products, and industrial testing. And these are markets that need rapid on-site tools for decision making. We're already generating revenue, and we're looking to grow. To date, we brought in over $150K in organic revenue, and we've completed our first hardware MVP unit, a portable proton accelerator. So typically an accelerator would be about the size of this room, a particle accelerator. We've built a small version of it. It's about 2 feet long and 3 feet high that allows you to do these measurements on site. We're now looking to scale through our laboratory services, our hardware deployments, and strategic partnerships. And our goal is to get to $20 million in sales by 2030 through a combination of our global laboratory footprint and a fleet of hardware units deployed on site, generating recurring revenue and real-time data streams. We've been fortunate to win over $1.7 million in non-dilutive awards here in the United States as well as in the European Union. We raised a small $300K pre-seed round showing our capital discipline, and we built a robust global IP portfolio that covers all aspects of this technology. In the United States, we're partnered with the Department of Defense and the EPA. In the European Union, we're partnered with Eurostars. We built a world-class team. Dr. Cordatema, the co-founder and the CEO, is an expert in analytical instrumentation and R&D with prior startup experience. Dr. Graham Peasley, the co-founder and chief scientific officer, is a world-renowned PFAS expert and particle physicist. Our additional leadership combines expertise in finance, marketing, as well as tech commercialization, in addition to the 8 full-time team members that we have here in the United States, specifically in the Midwest, and in the European Union. Now we're raising $1.5 million in a seed round to fuel the next phase of growth, specifically expanding our laboratory footprint so we can get a higher throughput on a per week and a per month basis. We're scaling our manufacturing capabilities to get more of these units into the field, and we're looking to strategically acquire both top technical and commercial talent to help drive market penetration and increase innovation within the company. So please join us in solving the PFAS crisis. If you'd like to learn more about the technology, please use the link here. Thank you.
All right, next up to the stage, Ganance. Let's give him a warm welcome.
Hello, everyone. Where do I point? Too far. That's me. We start here. Hello, everyone. My name is Alex Ocampo. I'm the founder and CEO of Ganance. And at Ganance, we are invisibly integrating health tracking with personal style because tracking your health should not be a fashion choice. Graduating from one of the top schools in the country was an incredibly proud moment for me and my family. Shout out to my brother out here. And to celebrate, our oldest brother bought me a beautiful gold Citizen Eco Drive as I was about to move to New York to take on my corporate job at IBM Watson and take on New York City. This was around 2014, 2015 when Fitbits and Apple Watches were getting popular, and I constantly found myself wearing my watch less and less because I really valued the data that these trackers provided. When my brother suffered a health scare a few years ago, I remembered the watch that he gave me that was sitting in a box collecting dust. I hadn't worn it in years because I chose my data over my personal style. And thankfully, my brother survived. But it was in this period that I first asked myself, why can't I have both? Why do I have to choose between my watch and my data? And it was this question that birthed Ganance. Today, if we want to track our health, we're forced to choose between being modern or being timeless, between honoring our past or staying ready for our future. Over the last decade, smartwatches and wristbands have done an awesome job showing us the value of tracking our daily health metrics, as demonstrated by the $153 billion wearable tech market. And at the same time, the global wristwatch market has soared to over $78 billion, and we sit at the intersection of both of these. I'd like to introduce you to the future of invisible wearables. I'd like you to see the Ganance Air live demo. Oh, activated it. Has music and media control. So our flagship product is this slim and invisible modular sensor that gives you the wellness info you need, like daily physical activity, biometric tracking, and the smart capabilities you love, like call and text notification, music and media control, and more. You might be asking, aren't there already great products out there that give me my health data? The answer is yes. Apple, Aura, Whoop, they've all built great products, and I've been a customer of all of them. But they're not perfect, and I don't want to wear them all the time. And I'm not just talking about when I need to look sharp for a wedding or to give a pitch. We are building for who we call our corporate athletes. Think high strivers, high achieving individuals, I'd argue everyone in this room, who need to show up for themselves, for their jobs, for their families, and we want to be their accountability partner to ensure they're reaching their maximum potential. We've delivered on the core need our customers asked for, which was to identify patterns in their daily movement and activity, and to help them be more intentional about the role technology plays in their lives by helping them remove a screen while still making sure they don't miss a notification. Our next generation product, which we are starting development on, will be a full-fledged wellness companion with biometric tracking on device and an AI assistant to give you the next best action recommendation and ensure that you're not missing any to-dos in your day-to-day. As we continue to evolve, our product footprint will continue to get smaller as utility increases, and with each iteration of the product, we're able to capture a larger and larger share of the market. How do we make money? We primarily drive revenue through high-margin hardware sales from the sale of our product, currently around 75% margin, even at our super low volume. We offer a premium data upsell or upgrade with offering biometric tracking through your phone's camera. So there's some really cool technology happening there, and we display that all through our simple and easy-to-use mobile app. And we're also building a suite of adjacent products which further help us raise average order value and establish ourselves as the leader in invisible tech. This can be accessories for, like an accessory band if you don't want to wear a watch, so sleeping, working out. And we're also building a new product that we're prototyping today. So if, let's say when we connect on LinkedIn after this, you just tap your phone to my watch strap. We've embedded technology to easily send information, tap into doors and key cards, in that same vein of making the technology that serves you invisible. We primarily go to market direct to consumer through a mix of organic social media content, paid ads, and email marketing. And we have an open rate on our email newsletter, which is tens of thousands of people, of 60 to 70%. So people are excited to hear from us and are waiting for us to tell them that we are out of pre-order. We see a big opportunity to expand into, or to reach our corporate athletes by expanding into corporate wellness programs, health and insurance plans, and corporate gifting. And then our third phase of our go-to-market is to go through brands and retailers, where at that point, our manufacturing will be scaled up where we can afford to give up the margin required to go through retail. So we are seeing strong early signs of a model that's ready to scale. Our summer production run was completely sold out, and we are now taking orders for our spring 2026 batch, which is also about 40% sold out. Again, we're at about 75% margin at our super low volume that we are at now, and that only goes up as we scale. And we are able to efficiently capture a customer with a customer acquisition cost of about $20 and return on ads about 7x. We're also seeing strong interest from top industry partners like Breitling, Casio, and the PGA, which show us that as we scale up, there are partners ready and willing to engage and even potentially provide an acquisition. So we have a strong team and network of supporters who are excited for our growth. My background is in bringing first-of-a-kind innovative products to market from my time at IBM Watson. Our engineering lead is a multi-exit founder who has scaled manufacturing to over millions of units. And our growth lead has implemented solutions at top consumer brands like Estee Lauder. We have a large and growing list of influencer partners ready to help us expand our reach and reach their audience. And we have advisors who have been where we're going, including Ben, who's former head of growth at Whoop, and product advisors who have led software and hardware teams at the top connected wellness companies like Fitbit, Google, Peloton, Amazon. So a nice watch lets you become anyone you want to be. Tracking your health ensures you're around long enough to become that person, and now you can do both with Ganance. We are building the next category-defining invisible tech company. Thank you.
All right, next up to the stage, we have Grounded. Let's give them a warm welcome.
Hello, everyone. My name is Sam Shapiro. I was an engineer at SpaceX before I started this company 3 years ago. I worked in Seattle and wrote software for the Starlink program. And before that, I ended up building a camper van during COVID and living in it and traveling around the country for about 6 months through national parks, state parks, campgrounds. And I worked full-time from this van. And so this really opened my eyes to what mobility could mean besides just getting from point A to point B. And I started Grounded in 2022, about 3 years ago. We launched the world's first electric camper van. But what I learned is a lot more about this whole world of what's called vehicle upfitting. So raise your hand if you've ever been in an ambulance before. Okay, keep your hands up. Raise your hand if you've ever eaten at a food truck before. Okay, keep your hands up. Raise your hand if you've ever had an Amazon delivery vehicle come to your house. Okay, so all of those vehicles that you guys have all seen and are ubiquitous require vehicle upfitting. So the OEMs like GM or Ford are not doing the shelving, they're not doing the kitchen inside. And so this is a whole aftermarket of vehicle upfitting, but there are problems. So there's very long lead times, there's a lot of one-off builds, and high degrees of customization if you need something custom. Or on the other hand, if there's high volume, you're picking from a set floor plan without much customization. There's no integrated electrical and power. You have generators that are costly, need a lot of maintenance, need replacement all the time. They're blowing exhaust, they're making noise. There's no ability to reconfigure these vehicles once you buy them, once the chassis is degrading. There's poor engineering a lot of times from some of these upfitters. There's quality issues. Poor customer service. And so with Grounded, what we've done is we've created the ability to do vehicle upfitting with customization at scale. And so what that means is we have a modular system that we've developed. You can think of it as Lego blocks for vehicle upfitting. And we've been developing this over 3.5 years, starting in the RV space and expanding into a bunch of these different commercial specialty sectors: healthcare, mobile command centers, food and beverage, marketing activations. And so customers can basically come to us and they can choose which modules they want inside their vehicle. And we've developed sort of the manufacturing system to do this at scale. We also have software that we develop both for the back end to power the manufacturing system of what we do at Grounded. We do all the manufacturing in-house. We're based in Detroit. We have a 12,000 square foot facility. We're moving into a bigger facility in a couple months. The team's about 25 people, half of which are technicians who physically assemble vans. We also do all of our own fabrication of these modules in-house. And we develop our own software to go inside the vehicle. So there's a full telematics solution powered by Starlink and cellular. It's really the only vehicle telematics solution out there that's actually for the interior of a specialty vehicle. So obviously there's Samsara, Geotab, vehicle telematics for the chassis, but there really isn't such thing for specialty interiors. So what does this look like if this video wants to play? But it doesn't, so you'll have to pretend that you saw what it looked like. But these are some 3D renders of different examples of what we do. Just kind of showing all the different possibilities when you configure your Grounded van. The team is made up of me. Our CTO was also at SpaceX. He worked on the Falcon Heavy. Then he built Amazon Leo's factory for their Starlink competitor. Nadia's been in industrial design and startups for basically her whole career. So we have a great team. I talked a bit about this already, the market of some of the problems in the vehicle upfitting space and sort of the spectrum between, on one end, you can go to a small shop, you can get something super custom, but it's a really long lead time. You're going to pay a lot of money for something very custom, or you go for something that's much more cookie cutter from somebody doing something at scale. So in terms of traction, we did about 5 million in sales last year. We're on track to do about 15 million in sales this year. We just hired a new director of sales for the company, which is our first sales leader at the company. He comes from one of the vehicle upfitting leaders in the space. These are just some more examples of a grounded command center versus sort of what's in the space today. And then on the bottom corner, you can also see the technology difference of the grounded plus software, which allows people to remotely monitor and control their vehicles. These are some more examples we're doing. We just shipped a fleet of dental vehicles for Colgate for their nonprofit to do community dental work all over the country. The top middle there is our RV product on the electric RV side. We're working on mobile x-rays for the New York City Department of Health. We shipped some vans to Nokia. We just unveiled our mobile coffee shop product. In terms of gross margins, it's anywhere from 20 to 40%. Really depends on the build out. The average selling price is anywhere from $200,000 to closer to $1 million for some of the more robust modules and technology that you can pick inside a grounded van. These are some of the OEMs we build on, so we're not building the chassis, right? We're buying the chassis from GM or Ford or Harbinger or Slate or Rivian, and we're doing that modular upfitting inside. These are great partners, these OEMs. They're also sales channels for us, so we work with dealerships all over the country who sell commercial vehicles. We work with RV dealerships. We also sell direct. And in terms of the market size, the RV market's a $70 billion market globally. These commercial vehicle sectors are tens billions more. There's hundreds of thousands of commercial vehicles getting shipped every year. So really an enormous opportunity in terms of the market out there. And these are some of our sales targets over the next few years. And one last thing I forgot to mention is we do have a patent pending for part of this modular system. And I think that's it. Thank you.
Next up to the stage, we have Maxwell Labs. Let's give them a round of applause.
Hello, everyone. So, I'm Jacob Balma. Let's see, CEO of Maxwell Labs. What is the button? Dude, 1 second. Uh-oh, Adobe's not responding. I can go without the... There we go. Okay. So I'm Jacob Balma, CEO and founder of Maxwell Labs. For 70 years, cooling has been mechanical. So think fans, liquids, pumps, and AI computing is pushing those systems to their limits. At Maxwell Labs, we're using the physics of light to engineer a new class of cooling device. We're a deep tech photonics company developing what we call photonic cooling. It's a new physical mechanism that uses light to extract heat from solid materials. We hold 9 patents protecting the platform. We've established partnerships with world-leading institutions, and we've raised nearly $10 million to bring this from theory into reality. It's validated physics, protected IP, and a clear commercial path. But to understand what we're building, you have to zoom out. Oh, can I go back? So think of the solar cell. It didn't improve the generator. It created a new way to generate electricity. The laser didn't redefine existing optics. it unlocked communications and precision manufacturing. The LED didn't tweak lighting, it redefined it. Each of those is a new physical platform, and photonic cooling sits in that same lineage. So we're not optimizing a cooling loop, we are laying the groundwork for a new industry. For decades, humanity has been learning to master light. We learned to harvest it, to generate it, and to emit it efficiently. And now we're learning to use it to cool. When heat constrains capability, photonic cooling removes the barrier. We're talking about data centers, defense systems, edge computing, power electronics, space, and quantum. Heat's not a niche problem. It's a universal constraint across industries. We're starting where the pressure is the greatest and the need is the most urgent. So computing is our beachhead. So AI compute is doubling roughly every 18 months. 30% of data center power goes to cooling. GPU power has exploded. And for the first time, chip performance isn't limited by transistor design, it's limited by heat. Compute needs a new solution, and that's where we enter. Advancements in AI compute are facing three major challenges: energy, heat, and performance. Together, these issues form a closed loop that is choking progress. Energy drives heat, heat limits performance, and performance drives more energy demand. In less than a decade, GPU power has increased sevenfold. Rack densities are pushing towards megawatt scale, not gradually, but exponentially. And let's talk about what's actually happening on the chip. Heat is emitted from microscopic hotspots that are smaller than a blood cell. These hotspots have power densities that are greater than the core of a nuclear reactor. Chips represent the most power-dense devices ever created by human beings. But cooling systems were designed to manage total power at the rack level. We can't cool the hotspots within the silicon fast enough. You can move the heat away, but you cannot extract it at the microscopic source quickly enough to prevent the chip from throttling. For more than half of an advanced chip can go dark because of this. It's just off. The problem isn't total power, it's power density. So photonic cooling, with photonic cooling, the problem is the solution. Instead of moving heat away from the chip, we convert heat directly into light. No fluids, no pumps, no moving parts. It's a solid state device that operates at thousands of watts per millimeter squared. Today's chips operate at tens of watts per millimeter squared. We solve the hotspot problem, and that opens an entirely new design space for chip architects. And not only that, but once you have the heat in the form of light, you can recover that optical power through basically a solar cell. And remember, you have 30% of the data center's power is going to cooling. If the efficiency is high enough in these photonic cooling systems, you can generate enough electricity from the waste heat of a data center to power the cooling system itself. So imagine there's no cost to cooling your data center. That's what this technology unlocks. So our platform integrates three things. There's a photonic waveguide network that distributes laser light across the chip surface, inverse design nanophotonic structures that precisely control light matter interactions, and anti-Stokes fluorescence cooling, the reverse laser cooling mechanism at the core of the technology. The physics has been demonstrated, and what we're doing now is we're engineering its integration. And so if we're going to look closer at this third pillar. Anti-Stokes fluorescence cooling was first demonstrated in 1995, and this is how it works. You take red laser light and you pump it into a material, and the chip's heat is used to further excite the material so that you get blue shifted, higher energy photons out. And when you do that, they carry away heat from the device. So why hasn't anyone done this yet? The materials used in the past have been very low efficiency, low power, and they were not able to actually design systems that were above like 1% efficient, okay? What's changed is that we now have the computational tools to explore this design space, okay? And we brought together world-leading physicists in nanophotonics, nonlinear optics, and inverse design to build this tool chain and do exactly that, manufacture these materials at scale. So when you're creating a new device, IP isn't a defensive tactic, it's the foundation. We have 7 patent families with priority back to 2018. We're protecting the mechanism, the architecture, and the integration pathway. We're building this to lead, not to license. And we're not doing it in isolation. We have active research collaborations with Sandia National Labs, Army Research Lab, and the University of New Mexico. Our scientific roots trace back to MIT, Princeton, and Cray Supercomputing. We've received over $875,000 in non-dilutive funding from the DoD, and these institutions don't partner lightly. They bring world-class manufacturing and research capability that's been directly accelerating our technical progress over the past 2 years, and their involvement serves as strong validation of both the scientific rigor of our platform and the significance of what we're building. This problem lives at the intersection of photonics, nanoscale heat transfer, and high-performance computing. That's where our team lives. So Cray Supercomputing, MIT Photonics, Princeton Physics, Sandia. It's the right team for a problem that requires deep physics and disciplined engineering. Where we're at today, we've raised $9.7 million. We've recently closed a $5.2 million from our Series A, which we've now extended to $8 million in total that we're closing out over the next 90 days. That capital's been funding lab build-out, team expansion, and our first demonstration of laser cooling in a semiconductor material that we're doing this year. And that demonstration will be an inflection point. It's a 20-year goal in laser cooling to do this demonstration in these materials. We've now moved from foundational validation to integration. In 2018, we were laying basically foundational IP, validating core physics, and the real momentum actually began in 2023 when we translated the theory into measurable lab results. In 24, we scaled the team, expanded the IP, and formalized partnerships. Now in 26, with capital secure and our lab build-out complete, we're moving to our first system-level demonstration of the platform. From there, we'll move into early access and then outward into power electronics, space, and beyond. So why now? The timing is perfect. AI compute is accelerating, thermal density is rising, energy constraints are tightening. The physics has been validated and the IP has been secured, so the team is assembled and our window's open. With that, I'd like to thank you for your time and interest. A special thanks to mHUB for their tremendous support over the years. And if you want to be part of building the next pillar of photonics, we'd welcome the conversation. Thank you.
All right, last but not least, we have Tom from Zemblen. Let's give him a warm welcome.
Thank you. Thank you. Awesome. Hi, everyone. My name is Tom Zhang. I'm the founder and CEO of Zemblen. And at Zemblen, we are leveraging robotics to bring fresh, healthy smoothies directly at the point of demand. When it comes to food, today's consumers are prioritizing wellness more than ever, and they're also demanding the convenience of having healthy food right at where they work and live. This is evident with some of the statistics coming out of the National Restaurant Association that shows that 74% of all food at restaurants are actually consumed off-premise, so they're either taken as takeout or delivery. This has fueled a massive growth in the food delivery space, but more and more customers are seeing the pricing pressures. For example, to get a smoothie delivered in Chicago, it's going to cost you $24. Furthermore, the food service industry is feeling the pressures of growing labor shortage. I'm sure many of you have seen your favorite restaurants having less and less opening hours time. And unfortunately, this is scheduled to continue growing with a projected 3 million jobs within food service unfilled in the US by 2030. And it's this backdrop at the dawn of ripe for disruption for the food service that we are launching our product. At Zemblen, what we've done is we've taken everything you love of a traditional smoothie bar, and we're leveraging robotics to make it into 16 square feet. You go up, you order your favorite smoothie, you customize it with things like protein, and you watch it blend right in front of you, fresh to order, in less than 3 minutes. We have 10 locations deployed throughout the city of Chicago
mainly in hospitals and universities. And we're also proud to be right here downstairs at mHUB. Our mission is to provide delicious smoothies that keep our customers coming back over and over. And we're proud to say that 60% of our sales come from repeat customers. And out of those, 50% come back weekly, with 25% coming back every other day, again, with the mission of providing healthy smoothie routines. With all that love, we're expanding with our existing location partners, Rush Hospital, University of Chicago, Northwestern. And to really accelerate go-to-market, we recently signed a contract with Compass Group, the world's largest food service provider that gives us access to over 10,000 locations nationwide. Now, companies like Compass love working with us because we're really disrupting the food service industry. If you look at everything from space to operating hours and labor, and most importantly, the fact that you can just pick up our kiosk and put it out the back of a truck to relocate, versus with traditional food service, there's leasing and build-out costs. Operationally, we plug directly into the food supply chain. We use standard pre-cut frozen ingredients with a shelf life of over 6 months. Now, coming out of an ecosystem like mHUB, we're excited to be building world-class technology. Right now, we're on our 8th generation of our kiosks with a reliability rate of over 99%. Each of our kiosks are mini data centers that we're actually using the capture to feed into our proprietary AI model to help control quality assurance at scale. Now, we're proud to be manufacturing directly here in Illinois, and our team is looking to both scale manufacturing and cut down costs as we continue to grow batch size. We get revenue both from our location partners in terms of monthly service fee, and we also get retail revenue from each smoothie we sold. We are able to get over 50% in contribution margins because our robotics technology allow us to bypass the costs associated with labor and rent, which gives us a path to a 6-month payback period per kiosk. And these robust unit economics is what allows us to truly be everywhere that people are in their daily routines. Our beachhead markets are universities and hospitals, and we see growth opportunity in terms of offices, residential lodging, gyms. All this equates to a 93,000 location market in the US alone, which translates to a $7.5 billion market. Now, it's been exciting times here at Zenblend. Over the last 12 months, we've grown from 2 to 10 kiosks and 5x our revenue. But we're really looking to take things to the next level, scaling up to 100 kiosks in the next 18 months, and also preparing the company to scale coast to coast with our mission to make the healthy option also the most convenient one. Now, I started this crazy company 6 years ago, right out of mHUB. Some of you guys might remember me blending smoothies by hand. And I also took the company through Chicago Booth's New Venture Challenge. But honestly, all the credit to what we were able to do goes to the team that we've been able to put together. Matt, our COO, is a former executive chef, wrote the food codes here for the city of Chicago, and previously scaled up to $100 million in food logistics. Our director of engineering, Dan, has been with the company for over 4 years, and it personally scaled and designed the over 3 generations of our technology. We're proud to be backed by world-class operators, including Luke Saunders, the founder and CEO of Farmer's Fridge, and Jeff Wilkie, the former CEO of Consumer for Amazon. And right now, we're excited to be closing our $6 million Series A. It's led by a private equity group, Promise Holdings, and they specialize in food, manufacturing, and retail. And we have some really great aligned institutional investors, such as the Apollo Ventures, Slauson & Co., the Illinois Invent Fund, and also the University of Chicago. And right now, conversations are going quickly, but we have the opportunity to bring on 1 or 2 partners who want to join us on this journey. And yeah, I mean, we're just excited to be placing more kiosks around the city of Chicago and allowing access and health to the communities that we're serving. And with that, really establish Chicago as a capital for robotics and automation across the US. Thank you, and feel free to come grab a smoothie downstairs if you haven't already.